The United States deployed a remarkable arsenal of anti-aircraft weapons during World War II, ranging from rapid-firing machine guns that could be operated by a single sailor, to massive guns capable of reaching aircraft flying in the stratosphere itself. This video examines every significant anti-aircraft weapon fielded by American forces across 4 years of global warfare. These weapons formed the defensive shield that protected soldiers on the ground, sailors at sea, and the American homeland from enemy air attack, accounting for thousands of enemy aircraft destroyed throughout the conflict. Let us begin with heavy machine guns, the weapons that provided the first line of defense against low-flying aircraft. The Browning M250 caliber machine gun became one of the most important American weapons of the entire war, serving in anti-aircraft, ground support, and aerial combat roles with equal effectiveness. John Browning began developing this legendary weapon near the end of World War I, after General John Pershing requested a large caliber machine gun capable of defeating armored aircraft and ground vehicles. The Army specified a weapon firing projectiles of at least half-inch diameter at velocities exceeding 2,700 feet per second. Winchester developed the massive .50 caliber cartridge, while Browning scaled up his proven M16 machine gun design to fire it. The resulting weapon entered service as the M1921 in water-cooled configuration. Development continued throughout the interwar years, with engineer Fred Moore working alongside Browning to refine the design. After Browning's death in 1926, Colt manufactured improved prototypes throughout the early 1930s. The air-cooled M2 heavy barrel variant emerged from this development process, featuring a thicker barrel that compensated for the loss of water cooling while reducing overall weight from 121 pounds to 84 pounds. When Japanese aircraft attacked Pearl Harbor on December 7, 1941, Browning .50 caliber machine guns were among the first American weapons to return fire. The .50 caliber destroyed more enemy aircraft than any other weapon during the attack. Messman Second Class Doris Miller manned an M2 aboard the battleship USS West Virginia, despite having never been trained on the weapon, defending his ship against attacking aircraft and earning the Navy Cross for his heroism. He became the first Black American service member to receive this decoration. Chief Petty Officer John Finn fired a Browning .50 caliber from an improvised position at Naval Air Station Kaneohe Bay throughout the attack, sustaining 21 separate wounds while continuing to engage enemy aircraft for over 2 hours. His actions earned him the Medal of Honor, the first awarded during World War II. At Hickam Army Airfield, soldiers retrieved AN-M2 aircraft machine guns from storage and positioned them within bomb craters, using the depressions as improvised fighting positions. On Ford Island, Marines and sailors set up .50 calibers on sandbag emplacements, constructed from whatever materials were available. Army Air Corps pilots, Second Lieutenant George Welch and Second Lieutenant Kenneth Taylor, managed to get airborne in P-40 Tomahawk fighters armed with fixed Browning machine guns. The two pilots shot down 7 Japanese aircraft between them during the attack, with Welch claiming 4 kills and Taylor 2 confirmed with 2 probables. Both received the Distinguished Service Cross for their actions. The M2 weighed approximately 84 pounds in its heavy barrel configuration and could fire between 450 and 575 rounds per minute. Its effective anti-aircraft range extended to approximately 1,800 meters against low-flying targets. The weapon could be mounted on virtually any platform, from small patrol boats to heavy bombers on tripods for ground use, or in powered turrets for vehicle mounting. The lighter AN-M2 aircraft variant weighed only 61 pounds, thanks to its 36-inch barrel and lighter construction. This version could achieve cyclic rates approaching 850 rounds per minute, substantially faster than the ground-mounted heavy barrel version. 6 wing-mounted .50 calibers became standard armament for fighters like the P-51 Mustang and P-47 Thunderbolt. B-17 Flying Fortress bombers carried up to 13 AN-M2 machine guns in various turret and waist positions. General Henry Arnold, Chief of the Army Air Forces, declared the Browning the outstanding aircraft gun of World War II. Field Marshal Hermann Goering reportedly stated that if the German Air Force had possessed the Browning .50 caliber, the Battle of Britain would have turned out differently. Over 1,960,000 M2 machine guns of all variants were produced during the conflict, making it one of the most manufactured American weapons of the war. The weapon saw service in every theater from the frozen Aleutian Islands to the tropical Pacific, from the deserts of North Africa to the skies over Germany. The M2 remains in active service today with military forces around the world, a testament to the brilliance of John Browning's original design. Moving on to automatic cannons, the next step up in anti-aircraft firepower. The 20mm Oerlikon cannon became the standard close-range anti-aircraft weapon for the United States Navy throughout World War II. This Swiss-designed weapon traced its origins to a German automatic cannon developed by engineer Reinhold Becker during World War I. The original Becker design saw limited production before the armistice. The patents passed to Swiss firms during the interwar years, eventually reaching the Oerlikon Machine Tool Works, where engineer Emil Georg Buhl oversaw continued development. Interestingly, the Imperial Japanese Navy provided funding in 1934 that saved the financially struggling company and enabled further improvements to the design. The Oerlikon Company refined the weapon throughout the 1930s, eventually producing a cannon that combined reliability with devastating firepower against aircraft. The Royal Navy began evaluating the Oerlikon in 1937 after Lord Louis Mountbatten advocated for its adoption. Initial bureaucratic resistance delayed acceptance until 1939, when newly appointed First Sea Lord Admiral Roger Backhouse supported the weapon. Britain placed orders for 1,500 guns, but the German conquest of France in June 1940 cut off supply routes from Switzerland. Only 109 guns reached British shores. British agents managed to obtain manufacturing drawings from the Oerlikon factory in Zurich, enabling domestic production to begin. The United States Navy purchased 2 Oerlikon guns for evaluation in 1935, but rejected them as inferior to ongoing .50 caliber machine gun development. By 1940, changing tactical conditions prompted reconsideration. The Bureau of Ordnance approved the Oerlikon for production in November 1940 after successful testing at the Dahlgren Proving Ground. Captain William Blandy, who supervised the tests, personally fired the weapon and recommended its immediate adoption. The first domestically produced Oerlikon was test-fired on June 8, 1941. By the time Japanese aircraft struck Pearl Harbor on December 7th, only 379 guns had been manufactured, far too few to adequately protect the fleet. Production accelerated dramatically after the attack. The Navy distributed manufacturing contracts to Hudson Motor Company, Pontiac Motor Division of General Motors, and other firms accustomed to precision manufacturing. Engineers had to adapt the Swiss watch-like mechanism design to American mass production methods. By war's end, American factories had produced over 124,000 Oerlikon cannons, with some sources citing figures as high as 150,000, including all variants and installations. The Oerlikon fired a half-pound explosive shell at 450 rounds per minute from a 60-round drum magazine mounted atop the weapon. The complete 60-round magazine could be emptied in approximately 7.5 seconds of continuous fire. Its effective range against aircraft was approximately 1,000 meters, though maximum ballistic range extended considerably further. A crew of 5 typically operated each gun, though a single sailor could fire it in emergencies. The weapon weighed approximately 150 pounds and required a substantial shoulder rest and handlebar system for aiming. The gun proved simple to maintain, with only 5 major breakable parts. Barrel changes could be accomplished in under 30 seconds. The weapon could be mounted almost anywhere on a ship, bolted to virtually any flat surface where space permitted. Battleships carried dozens of Oerlikons by war's end. The carrier USS Saratoga mounted over 50 of these weapons at one point during the conflict. The gun proved particularly effective during 1942 and 43, when American naval forces fought desperate defensive battles across the Pacific. At the Battle of Midway in June 1942, Oerlikons contributed to the destruction of Japanese aircraft attacking the American carrier task force. However, the advent of Japanese kamikaze attacks in late 1944 revealed the Oerlikon's limitations. Its 20mm shells often failed to destroy or disable aircraft quickly enough to prevent suicide crashes. The relatively light projectile could not reliably detonate aircraft fuel tanks or disable engines in the brief moments before impact. The gun remained in service throughout the war for its psychological value, allowing sailors to actively engage attacking aircraft rather than waiting helplessly. The Navy developed twin mounts and tested experimental triple mounts to increase firepower. Triple mounts designed at Pearl Harbor were ordered, but testing aboard the carrier USS Enterprise during 1943 showed the center gun was difficult to load, and the order was cancelled. Despite its limitations against kamikazes, the Oerlikon earned the respect of sailors who appreciated its reliability and the sense of agency it provided during air attacks. The 37mm gun M1 was the United States Army's standard light anti-aircraft gun at the war's outbreak, representing the first domestically designed weapon of its class. John Browning himself had contributed to early development of this weapon during the 1920s before his death in 1926. The Army began serious development in 1935 after recognizing the need for a weapon more powerful than machine guns but lighter than heavy anti-aircraft artillery. The M1 entered service in 1939, filling the gap between the 50 caliber machine gun and the 3-inch anti-aircraft gun then in Army service. The weapon fired a 21-ounce explosive shell fitted with a self-destruct mechanism set for approximately 10,500 feet altitude. This prevented unexploded shells from falling back to Earth and endangering friendly troops or civilians. Maximum horizontal range reached approximately 8,850 yards, though the self-destruct would activate after approximately 4,000 yards of horizontal flight. A crew of 7 operated the gun, which could achieve rates of fire between 90 and 120 rounds per minute, depending on crew proficiency. Ammunition fed from 10-round clips. The complex M5 fire director and M1 remote control system allowed 2 guns to be coupled together for coordinated engagement of targets. The M5 generating unit provided electrical power for the remote control system. When the remote system was inoperative, crews could use the simpler M5 sighting system for manual engagement. The M1 saw combat throughout the early years of American involvement in the war. At the defense of the Philippines beginning in December 1941, 37mm guns provided critical air defense for American and Filipino forces on Bataan and Corregidor. The 200th Coast Artillery Regiment, a New Mexico National Guard unit, declared the best anti-aircraft regiment available on August 17, 1941. received most of its actual equipment only as it boarded transport ships in San Francisco. Training at Fort Bliss had been conducted with only a single gun per battery and no ammunition. Despite these limitations, the regiment claimed numerous Japanese aircraft during the desperate months of resistance before the eventual surrender. However, the Army quickly recognized that the 37mm lacked the range and hitting power needed against modern aircraft. Testing of British-supplied Bofors 40mm guns in December 1940 revealed a superior weapon in virtually every respect. The Bofors fired a heavier shell with greater range and proved more reliable under combat conditions. By April 1941, the Army had formally decided to replace the 37mm with the Bofors as quickly as production permitted. The M1 remained in service throughout the war due to production limitations, but automatic weapons battalions progressively converted to the 40mm as supplies allowed. The 37mm also found a secondary role mounted on the M16 combination gun motor carriage alongside twin 50 caliber machine guns, providing mobile anti-aircraft protection for armored columns. A naval variant, the M9 autocannon, served on PT boats in the Pacific Theater around 1944, replacing the earlier M4 autocannon. The 40mm Bofors gun M1 became the most important medium anti-aircraft weapon employed by American forces during World War II, and arguably the most widely used anti-aircraft gun of the entire conflict by any nation. This Swedish-designed weapon was developed by AB Bofors beginning in 1929 with funding from the Swedish Navy. A prototype appeared in November 1931, with the design approved by 1932. Foreign orders came quickly, with the Dutch Navy becoming the first export customer in August 1934, when they ordered 5 twin-gun mounts for the cruiser De Ruyter. The following year, Bofors revealed a towable field carriage that expanded the market to ground forces. By 1939, 18 nations had purchased or licensed the Bofors for their own forces. The British Army tested Polish-built versions in 1937 and eventually accepted them as the QF 40mm Mark I gun. The United States obtained a British-manufactured example for testing in December 1940. Trials at Aberdeen Proving Ground demonstrated the Bofors' clear superiority over the American 37mm gun. The weapon fired a heavier 2-pound shell with greater range while proving more reliable and easier to maintain. The Army standardized the Bofors as the 40mm automatic gun M1 in May 1941. However, the original Swedish design proved completely unsuitable for American mass production methods. Swedish drawings used metric measurements unfamiliar to American manufacturers and required extensive hand-fitting during assembly. Notes on Swedish blueprints included instructions such as file to fit at assembly and drill to fit at assembly, requiring skilled craftsmen rather than assembly line workers. One American engineer reportedly joked that the gun was clearly designed to eliminate the unemployment problems of the Great Depression. The Navy Department worked intensively with Chrysler Corporation to redesign the weapon for mass production. Chrysler received a contract for 2 pilot weapons in February 1940. Engineers essentially recreated the Bofors from the ground up, adapting it for American manufacturing techniques while maintaining its combat effectiveness. A contract with Swedish manufacturer Bofors for licensing rights was signed on June 21, 1941 for $600,000, granting exclusive rights to manufacture the weapon in the United States. Production finally reached significant levels in 1943. Chrysler ultimately manufactured 60,000 guns and 120,000 barrels during the war at half the originally projected cost, filling Army needs by late 1943. The Naval Gun Factory in Washington, D.C. and York Safe and Lock Company also contributed to production. The Navy required water-cooled versions for shipboard use, as air-cooled guns could not sustain the prolonged firing necessary during naval engagements. Naval versions achieved cyclic rates of 160 rounds per minute, compared to 120 for Army air-cooled models, though practical rates were closer to 60 to 90 rounds per minute due to manual loading from 4-round clips. The 40mm Bofors became the backbone of American naval anti-aircraft defense during the Pacific Campaign. By war's end, Iowa-class battleships carried 80 Bofors guns in twin and quadruple mounts, while Essex-class carriers mounted 72. The quadruple mount was developed by essentially mounting 2 twin mounts side by side, with power operation added to both configurations. Between October 1, 1944 and February 1, 1945, when kamikaze attacks reached their peak intensity, Navy Bofors guns accounted for fully half of all aircraft shot down by surface ships. The Navy was so satisfied with the weapon's performance that it developed a practice of telegraphing Chrysler Corporation with the serial numbers of guns that had shot down enemy aircraft. The weapon proved effective against even diving kamikazes when directed by the Mark 51 gun director, an electromechanical computer that calculated lead angles for gunners. Up to 4 power-assisted Bofors mounts, meaning up to 16 guns, could be slaved to a single gun director for concentrated fire. This proved one of the few effective methods of stopping high-speed kamikaze attacks during the final year of the Pacific War. The Army employed its 40mm guns in automatic weapons battalions that provided mobile air defense for ground forces. These battalions typically paired Bofors guns with quad 50 caliber mounts, creating overlapping defensive zones against aircraft at different altitudes and ranges. Army units used single-barrel weapons on 4-wheel towed carriages with crews of 7, including a squad leader, gunner, assistant gunner, 2 loaders, and 2 ammunition bearers. Let us now examine heavy anti-aircraft artillery, the powerful guns that defended against high-altitude bombing attacks. The 3-inch gun M3 served as the primary heavy anti-aircraft weapon of the United States Army when the war began, representing a direct lineage to America's first dedicated anti-aircraft weapons. The 3-inch M1917 was the United States Army's first purpose-built anti-aircraft gun, entering service during World War I. Development started in 1915, taking 2 years to produce a functional weapon. The M1917 was essentially an unmodified 3-inch M1903 coastal defense gun barrel mounted on a fixed platform allowing high-angle fire. Only a few were built, as the similar 3-inch M1918 on a mobile mount proved more practical. In the late 1920s, M1917 and M1918 guns were fitted with removable barrel liners and redesignated 3-inch M1, M2, or M3, depending on the original variant. The M3 proved most numerous, entering service in 1928 with an auto-fretted liner that extended barrel life and simplified maintenance. A battery of M3 guns typically consisted of 4 weapons, with associated range-finding and fire director equipment. The 3-inch shell could reach aircraft at altitudes up to approximately 27,000 feet, adequate for engaging the slower aircraft of the 1930s, but increasingly inadequate against modern bombers flying faster and higher. By 1938, the Army recognized that improvements in aviation technology would soon render the 3-inch gun obsolete. Development contracts were issued for both a new, heavy anti-aircraft gun of 90mm caliber and a super heavy weapon of 120mm caliber. Experimental upgrades to the 3-inch gun designated T8 and T9 were cancelled when the new 90mm design proved far superior. Nevertheless, the M3 remained in service throughout the war due to production limitations on replacement weapons. 3-inch guns defended airfields and installations across the Pacific during the early years of the conflict. At New Guinea, the Philippines, and other forward areas, gun crews engaged Japanese aircraft with these World War I-era weapons when nothing better was available. Gun crews of Battery D, 208th Coast Artillery, at the new fighter strip at Dobodura, New Guinea manned their 3-inch guns as late as May 1943. The 3-inch gun barrel later found new life as the main armament of the M10 tank destroyer after being adapted for the anti-tank role as the 3-inch M7 gun. A total of 6,824 M7 guns were manufactured for this purpose. The 90mm gun M1 became the standard heavy anti-aircraft gun of the United States Army from 1940 onward and remained so throughout the war and beyond, earning comparison to the legendary German 88mm flak gun. Development began on June 9, 1938, when the Army issued contracts for a new anti-aircraft weapon with the largest caliber projectile that could still be manually loaded at high elevation angles. A separate contract addressed a 120mm weapon using mechanically assisted loading for the super heavy role. Engineers at the Watervliet Arsenal produced the initial 90mm design, which entered production as the 90mm gun M1 in March 1940. Production was contracted to Alice Chalmers beginning in November 1940, with the first unit shipped in September 1941. The M1A1 variant followed in late 1940 with improvements including a spring-assisted rammer on the breech and an improved mount that increased the rate of fire to 20 rounds per minute. This version was accepted as standard on May 22, 1941. Several thousand M1A1 guns were available when America entered the war in December 1941. The weapon weighed approximately 32,000 pounds in firing position. The 90mm fired a 23-pound projectile at a muzzle velocity of 2,700 feet per second. Maximum effective altitude exceeded 33,000 feet, with an absolute ceiling approaching 43,500 feet. Horizontal range exceeded 19,000 meters. These capabilities allowed the weapon to engage virtually any bomber aircraft then in existence. A typical battery of 4 guns was controlled by the M7 or M9 gun director, coupled with the kerosene predictor for fire control calculations. Production accelerated throughout the war, eventually reaching several thousand guns per month. Each complete weapon required up to 30 separate contractors to manufacture at a cost of approximately $50,000. Over 7,890mm guns of all variants were produced during the conflict. The M2 variant, introduced in May 1943, addressed a significant limitation of earlier models. Unlike the German 88 or British 3.7-inch gun, the original M1 and M1A1 mounts could not depress low enough to engage ground targets. The M2 introduced a new mount featuring single-axle front and rear bogies, folding platforms, and armor shielding for the crew. Most importantly, it could depress to 10 degrees below horizontal, allowing engagement of tanks, vehicles, and fortifications. An electrically assisted rammer increased the rate of fire to 23 to 28 rounds per minute. It was not necessary to fully emplace the M2 before firing, enabling rapid engagement of both air and ground targets. The 90mm gun earned lasting fame, defending against German V-1 flying bomb attacks on Antwerp, Belgium during the winter of 1944 to 45. American anti-aircraft batteries deployed around the vital port city created a defensive barrier designated the rocket shield by planners. The weapons were ideally positioned along the trajectory of incoming V-1s, allowing engagement well before the missiles reached their targets. During the campaign from December 1944 through March 1945, American batteries destroyed over 2,183 V-1s. During 1 week near the end of the campaign, 90mm batteries achieved a 94% kill rate against incoming missiles. This success resulted from the introduction of the SCR-584 radar fire control system beginning in 1944. This microwave radar could track targets with accuracy to within 1 mil, approximately 0.06 degrees, and transmitted targeting data directly to the M3 gun data computer developed by Bell Laboratories and M9 Director. These systems calculated firing solutions automatically, requiring gun crews only to load and fire. Proximity fuses, designated VT for variable time, detonated shells automatically when they passed within lethal distance of a target rather than requiring a direct hit. The combination of accurate radar tracking, computerized fire control, and proximity fuses transformed the 90mm from a weapon system that required hundreds of shells per kill into a precision instrument. When controlled by the SCR-584 radar, the 90mm M1 was considered by many the finest anti-aircraft gun of World War II. The ammunition demands were enormous. During February 1945, ammunition supplies ran critically low despite emergency deliveries by air. For much of the period from December 1944 through March 1945, nearly every 90mm barrel produced went to Antwerp. Anti-aircraft units in the Pacific and Mediterranean had to wait. Gun tubes wore out after 1,500 to 2,000. Rounds and many batteries exhausted 3 or 4 complete sets of barrels during the campaign. The Coast Artillery Corps also employed 90mm guns for harbor defense beginning in 1943, organizing them in anti-motor torpedo boat batteries, typically combining 4 90mm guns with 237 or 40mm weapons. The 120mm gun M1 was the largest anti-aircraft weapon produced by the United States during World War II, capable of engaging aircraft at altitudes no other American ground-based weapon could reach. Development began concurrently with the 90mm gun in 1938, when the Army sought both heavy and super-heavy anti-aircraft weapons. The 120mm design traced its origins to a prototype produced in 1924 that had been shelved as too heavy and expensive for practical use. Rising tensions in Europe and Asia prompted the Army to revisit the concept and mate the large-caliber gun to a new 8-wheeled transport carriage. The weapon entered service as the 4.7-inch M1 in 1940, before being redesignated 120mm gun M1 in 1944 when the Army adopted metric designations. This massive weapon could fire a 50-pound projectile to an altitude of approximately 60,000 feet, earning it the nickname Stratosphere Gun. The shell traveled at a muzzle velocity of 3,100 feet per second. Maximum horizontal range reached approximately 81,000 feet at 45 degrees elevation. A crew of 13 operated the gun, including a commander, 9-man gun crew, and ammunition handlers. Additional personnel operated fire control equipment, including the SCR-584 radar and M10 auxiliary predictor. Powerful searchlights illuminated targets during nighttime engagements. The complete weapon weighed approximately 49,000 pounds in travel configuration with its 8-wheel carriage. Approximately 550 120mm guns were produced during the war. The vast majority served in static defensive positions protecting critical installations within the continental United States. The Army Anti-Aircraft Command formed 44 active duty and 22 National Guard battalions equipped with M1 guns divided into 7 brigades and 20 anti-aircraft artillery groups. 2 Canadian anti-aircraft battalions also received M1 guns for joint defense of the strategic Sioux Locks Canal system. Batteries defended nuclear production facilities at Oak Ridge and Hanford, aircraft factories, strategic Air Force bases, and major population centers against the possibility of long-range enemy bomber attack. 15 guns deployed to the Panama Canal Zone for protection of that critical waterway. 4 reached Northern Ireland for defense of American installations there. 1 battalion, the 513th Anti-Aircraft Artillery Gun Battalion, deployed to the Philippines in February 1945 with their massive weapons. Special tracks and heavy cranes were required for transport and assembly. However, Japanese air power had been so thoroughly destroyed by that point in the war that the battalion never fired its guns in anger against hostile aircraft. The 120mm M1 thus holds the distinction of being the largest American anti-aircraft gun of World War II that never engaged an enemy aircraft in combat. The weapon remained in service through the Korean War and into the early Cold War period before being replaced by Nike Ajax surface-to-air missiles beginning in 1954. The gun's design later influenced the 120mm tank gun developed for the T-34 heavy tank prototype and eventually the M103 heavy tank. Let us move on to self-propelled anti-aircraft systems, the mobile weapons that protected armored columns and advancing ground forces from air attack. The M13 multiple gun motor carriage was the first American self-propelled anti-aircraft vehicle to see widespread service during the war. This weapon mounted the M33 Maxim twin 50 caliber machine gun turret on an M3 half-track chassis. Development began in 1941 when the Army recognized the need for mobile anti-aircraft protection that could keep pace with armored formations during offensive operations. The M33 turret mounted 2 Browning M2 heavy machine guns on a powered mount capable of 360-degree traverse and elevation from -10 to +90 degrees. Electric motors powered by batteries recharged from a small generator allowed rapid tracking of fast-moving aircraft. The Maxim Corporation of New York developed the turret system. The M13 entered production in mid-1942 and saw combat in North Africa beginning in late that year during Operation Torch. However, battlefield experience quickly demonstrated that twin 50 calibers provided insufficient firepower against modern aircraft. Pilots could often survive long enough to complete their attack runs, even after taking multiple hits from the relatively light 50 caliber rounds. The Army sought increased firepower almost immediately after the M13 entered service. The M16 multiple gun motor carriage answered the Army's demand for greater anti-aircraft firepower by mounting the M45 quad-mount turret on an improved M3 half-track chassis. The M45 turret carried 4 Browning M2 heavy machine guns instead of 2, effectively doubling the volume of fire compared to the earlier M13. The Maxim Corporation developed the quad-mount turret during 1942. Building upon their experience with the twin-mount design. Production contracts went to White Motor Corporation. A prototype designated T61 was tested at Aberdeen before acceptance as the M16 multiple gun motor carriage. A pilot vehicle received corrections including addition of a gun shield before production commenced. 2,700 M16s were produced between May 1943 and March 1944, with an additional 568 M13s and 109 T10 half-tracks converted to M16 configuration. The M16 earned the fearsome nickname Meat Chopper for its devastating effectiveness against both aircraft and ground targets. 4 50 caliber machine guns firing simultaneously could put approximately 2,000 rounds per minute into a target area, creating an almost solid stream of heavy bullets. The M45 turret was powered by electrical servos running on 2 6-volt batteries recharged by a small engine-driven generator. A gunner seated in a central armored cockpit controlled the turret using a large spiderweb-type graduated sight with LED elements built in for engaging moving aircraft. 2 loaders kept the ammunition belts feeding smoothly. Standard practice was to alternate between the upper and lower pairs of guns, allowing unused barrels to cool and extending engagement time. The weapons could be tuned to converge their fire at specific ranges, concentrating maximum destructive power on targets at the crew's chosen distance. By the time American forces invaded northwest Europe in June 1944, Allied air superiority was so complete that German aircraft rarely appeared over the battlefield. The M16's fearsome firepower turned increasingly against ground targets. The weapon proved devastatingly effective against exposed infantry, soft-skinned vehicles, and light fortifications. Soldiers gave it additional nicknames, including Krautmower, for its effectiveness against German troops. During the Battle of the Bulge in December 1944, M16s provided critical fire support against German infantry attacks when conventional artillery was unavailable or overwhelmed. The psychological effect of 4 simultaneous 50 caliber machine guns was often as devastating as the physical damage they inflicted. 1,000 M17 variants were produced using the M5 half-track chassis by International Harvester from December 1943 to March 1944 for delivery to the Soviet Union under the Lend-Lease program. Soviet forces made extensive use of these vehicles, with up to half of Soviet air defense forces reportedly consisting of M17 vehicles by war's end. The M16 remained in service through the Korean War, where it was used primarily for ground support given American air superiority. The M15 combination gun motor carriage mounted both a 37mm automatic cannon and twin 50 caliber machine guns on an M3 half-track chassis. This design attempted to combine the hitting power of the 37mm gun with the rapid engagement capability of machine guns. The M15 entered service alongside the M16 and typically operated with those vehicles in automatic weapons battalions. The 37mm gun provided greater range and destructive power against aircraft at medium distances, while the 50 calibers engaged close-range targets. The combination allowed a single vehicle to engage aircraft throughout their approach, rather than being limited to either close or medium range. However, the complexity of the dual weapons system and the general obsolescence of the 37mm gun limited the M15's popularity compared to the Quad 50 M16. Both vehicles frequently work together, with the M15 providing medium-range capability while M16s covered close defense. The M19 gun motor carriage entered development late in the war to provide even greater mobile anti-aircraft firepower. This vehicle mounted twin 40mm Bofors guns on the chassis of the M24 Chaffee light tank. The combination promised exceptional firepower, along with the mobility and armor protection of a fully tracked armored vehicle. Development proceeded throughout 1944 and early 1945. However, the vehicle arrived too late to see significant combat during World War II. The M19 would prove its worth during the Korean War, where its twin Bofors guns were used extensively against ground targets when Communist forces proved unable to mount significant air attacks against American positions. American forces also employed the 50 caliber M45 quad mount on the M51 multiple machine gun carriage, a towed trailer mount that provided the same firepower as the M16 half-track without the mobility. The M51 was used alongside towed 40mm Bofors guns in anti-aircraft regiments, with the Quad 50 providing close-range defense while the Bofors covered medium altitudes. This combination proved effective until the M55 machine gun trailer mount replaced the M51 toward war's end. Finally, naval anti-aircraft systems beyond the guns already discussed deserve mention for their contribution to fleet defense. The 5-inch 38 caliber dual-purpose gun served as the primary heavy anti-aircraft weapon aboard American warships throughout the Pacific War. Though designed as a multi-purpose weapon capable of engaging both surface and air targets, its anti-aircraft capability proved essential during carrier task force operations. These weapons armed destroyers, cruisers, battleships, and aircraft carriers, providing long-range defense against high-altitude bombing attacks. The Mark 37 Fire Control Director guided the 5-inch guns using radar and mechanical computers, calculating the complex lead angles necessary to hit fast-moving aircraft at extreme range. While primarily a surface warfare weapon, the 5-inch 38 proved capable of engaging aircraft at ranges where smaller anti-aircraft guns were ineffective. Its heavy shell could destroy aircraft with near misses when fitted with proximity fuses, an advantage smaller weapons lacked. The combination of 5-inch guns for long-range engagement, 40mm Bofors for medium range, and 20mm Oerlikons for close defense created overlapping zones of fire that made attacking American warships extremely hazardous. By the final year of the war, even massed kamikaze attacks frequently failed to penetrate the defensive screens of American task forces. The 1.1-inch gun was an early American naval anti-aircraft weapon that proved disappointingly ineffective in combat. This weapon, firing a 28mm projectile from water-cooled quad mounts, was developed during the 1930s as the Navy's primary close-range anti-aircraft gun. When Japanese aircraft struck Pearl Harbor, the 1.1-inch gun and 50 caliber machine gun represented the Navy's primary close-range anti-aircraft armament. Neither proved adequate against determined attack. The 1.1-inch gun suffered from mechanical complexity that led to frequent jamming at the worst possible moments. Its hitting power also proved insufficient against modern aircraft construction. Following Pearl Harbor, the Navy accelerated replacement of the 1.1-inch with the far superior 20mm Oerlikon and 40mm Bofors. By mid-war, few 1.1-inch guns remained in frontline service, having been stripped from vessels during refits and replaced with proven foreign designs. Throughout World War II, American anti-aircraft weapons evolved from the inadequate systems available in December 1941 to sophisticated defensive networks that could destroy aircraft with unprecedented efficiency by 1945. The 50 caliber Browning machine gun proved itself in countless engagements from Pearl Harbor to the final days of the war, earning the nickname Ma Deuce that soldiers still use today. The 20mm Oerlikon and 40mm Bofors became the primary naval anti-aircraft weapons, with over 120,000 Oerlikons and tens of thousands of Bofors guns arming American warships from patrol craft to battleships. The 90mm gun achieved remarkable success defending Antwerp against V-1 attacks, demonstrating the potential of radar-directed, proximity-fused anti-aircraft fire that would define air defense systems for decades to come. Self-propelled systems like the M16 Meat Chopper provided mobile protection for ground forces and proved equally devastating against infantry when air targets were unavailable. The American anti-aircraft arsenal of World War II reflected the nation's industrial might and engineering capability. From the venerable Browning machine gun conceived before the First World War to sophisticated radar-directed gun systems that foreshadowed modern air defense, these weapons protected American forces across every theater of the conflict. The 120mm Stratosphere Gun reached higher than any previous ground-based weapon, though it never fired against enemy aircraft. The humble 20mm Oerlikon defended thousands of vessels against attack. Each weapon played its role in the greatest conflict in human history, and their legacy continues to influence military technology decades after the last shots were fired in August 1945.